How you doing?
Nice perks, Andy.
Welcome, welcome. We are going to get started. I am Patrick Briscoe and Marshall Coffey, all wrapped up in one. I'm going to channel him tonight. Patrick, of course, is gone. He's on a mountain. Wish I was on a mountain, you know, but no, I'm glad to be here with you, and I'm excited about tonight. It's an exciting topic. Glad that you came, and glad that you're part of this study. If you're reading along, this is chapter 6. So you can, we'll stay here a couple of weeks. We'll be here again next week on some things. And so we don't have to nail it all down tonight. And I'm going to present to you quite a bit of material. I am not a master of this material. So what I'm going to share with you is what the book teaches. Primarily, anyway. And we'll talk about some implications at the end of that. So, any physicists in the room? Anybody currently in a physics class? Really? Uh-oh. So you may have to correct me on some things. You made a C. Luke was joking with me about that saying physique, you know, so. Might be better if it did. This will be fun. So let's join together in prayer. Father, thank you so much for the chance to gather, to study, to encourage one another, to contemplate your glory and goodness, and the incredible, powerful mystery that you are. And as much as we've discovered in science, we have yet to even scratch the surface of understanding all that you have done. And we were not there. We did not see it. We come to these things humbly. And tonight, as we share this material that was prepared for us, we ask that you would enlighten our hearts and minds, and give us something to contemplate in our own faith, and also as we share faith with others. So bless our study. We pray this in the name of Jesus. Amen.
Amen.
All right, so lots of material tonight. Let's just start with what's simple. What is physics? And so we can talk about physics being a natural science that involves the study of matter and motion through space and time. It has to do with energy and force. And so the goal of physics is to understand how the universe behaves. So you can bring in my friend Isaac Newton and the apples that fell on his head. Interestingly enough, you might like to know that there were no apples that actually hit Isaac on the head. Did you know this? So later on, the story came out that he was with a friend, and he went out after dinner, and it was warm. They went into the garden drinking tea, and there was some shade there under the apple trees, and he told me that it was just such a circumstance as this, the guy says in reports, that Isaac said that it was this occasion that the fall of the apple happened, and he was in an especially contemplative mood when he saw the apple fall to the ground. And he wondered, now why didn't it go sideways? Why did it fall down? So it didn't actually hit him on the head, but you get this kind of an idea. Physics. One of the main things that you'll find in the book is the idea of the anthropic principle. Is that a new concept? Anybody familiar with it? If you've read the book, hopefully you're familiar with it. But outside of that, is it a new concept? Yeah? Okay, so anthropic. What does anthropic mean? It comes from the Greek word anthropos. And it just simply means man. And so there is this principle that says, or as Patrick Glenn points out, he defines it this way: all the seemingly arbitrary and unrelated constants in physics, which are precisely the values you need if you want to have a universe capable of producing life. So the anthropic principle says that we live in a universe that if it was tweaked, even just a little to the right or to the left, small changes that change the properties of physics, that we would not be capable of life in this universe. But the fact that we find ourselves here, that we are alive in this universe, and that everything is so finely tuned, means that we would have to investigate it. How is that? How is it possible? Tonight, what you will find, I'm going to present to you material from the book that makes this fine-tuning, this anthropic principle, hopefully more clear. I hope you leave with a little more clarity on how finely tuned the universe is. Alistair McGrath asked these two questions related to the principle. He says, number one, is it pure coincidence that the laws of nature are such that life is possible? So is it possible it all just fell together like this? That it happened perfectly? That'll have to be what you, at least in part, answer tonight. Is that a possibility? Question number two, might this not be an important clue to the nature and destiny of humanity? So those are good questions that we could start with tonight. Anthropic principle. In speaking of this principle, then, Paul Davies, who was at one time a skeptic, former professor of theoretical physics at the University of Adelaide, said this: "Through my scientific work, I have come to believe more and more strongly that the physical universe is put together with an ingenuity so astonishing that I cannot accept it merely as brute fact." So, in his skepticism, you've got a guy that is a theoretical physicist, and he's saying, as I look at what I see, as I look at the evidence, I cannot accept it as merely a brute fact, as merely something that just happened. Consider Robin Collins. Now, this is the guy. As you may know, in this book, what Lee Strobel does is he interviews experts in these fields. So Robin Collins is the expert that he interviews, primarily the one for physics. And this is a couple of things that he says, that Robin Collins says. He says, over the past 30 years or so, scientists have discovered that just about everything about the basic structure of the universe is balanced on a razor's edge for life to exist. The coincidences are far too fantastic to attribute this to mere chance or to claim that it needs no explanation. Later on he says, by far the most pervasive current argument for the existence of God, in speaking of the anthropic principle. So here's somebody again that in doing extensive research and study says the coincidences are far too fantastic. That we have life on this earth, that everything works so perfectly together, too fantastic for it to happen accidentally. There's an example in the book I'd like to share with you that Robin Collins gives. It's on my page 130. It wouldn't be on yours. But shortly into the interview with Robin Collins, if you were looking in your book, it says the impression of design is kind of the subheading. And I'd like to share with you the analogy that he gives to express the fine-tuning or the anthropic principle. He says, I'd like to use the analogy of astronauts landing on Mars and finding an enclosed biosphere. So they're on Mars, they find this biosphere. Sort of like the dome structure that was built in Arizona a few years ago. At the control panel, they find that the dials for the environment are set just right for life. The oxygen ratio is perfect. The temperature is 70 degrees. The humidity is 50%. There's a system for replenishing the air. There are systems for producing food, generating energy, and disposing of waste. Each dial has a huge range of possible settings, and you can see if you were to adjust one or more of them just a little bit, the environment would go out of whack and life would be impossible. What conclusion would you draw from that, he says. So, what conclusion would you draw from that if you were on Mars and found a dome structure and it was perfectly set?
Somebody was expecting it.
Yeah, somebody's been here, right? There was an intelligence here. And so the answer is obvious. He says that someone took great care in designing it and building it. And so that is kind of this idea of what we have with the anthropic principle. Okay, let me give you some examples of fine-tuning to elaborate on the principle. So gravitational force. First of all, let me share with you three geniuses, that have helped us to understand gravity. Okay, first, I've already mentioned him. You know who that is? Isaac Newton. I'm not sure if that's a good hair day or a bad hair day.
It's a hair day.
It's a hair day. He's got some hair. Here's another one. That's definitely a bad hair day. You know that guy. And then finally, the third genius, well known. You may not be able to see it, but that's me. And right about, let's see, where's my little thing? Can't remember where my pointer is. There it is. I don't know if you can see it, but I'm sticking my tongue out as I skydive. That's my best impression of Einstein. This was back in 1995. I went skydiving. Anybody gone skydiving? Few? It's awesome, right? I was falling at 120 miles an hour at this point when this picture was taken. So I know a little bit about gravitational pull. It was interesting, this guy over here that was jumping with me, he was one of the ones that was, there was a guy taking photos, and then this guy was just kind of out playing and doing stuff with me. And my instructor said, pull your cord, and I pulled my cord, and whenever I did, these guys who were with me went, pew, and were gone. And it was the first moment that I had a clue how fast I was falling, because I had a point of reference. Before that, I didn't have a point of reference. I knew I was falling. But when I saw those guys just disappear in an instant, falling at 120 miles an hour, I knew, yeah, gravity works. Gravity works. So gravitational force is one of the great examples of fine-tuning. And here's why. Because, and by the way, there's a video toward the end that is going to elaborate on this and give you a really great example that's very visual. So I'm setting you up for some of that, and then you'll have some reinforcement from the video. But basically, compared to the total range of forces of gravity in nature, gravity has an incomprehensibly narrow range for life to exist. In other words, if you go just a little bit either direction of stronger or weaker, and it all falls apart. A little bit stronger, and there's no way you and I, even just a tiny bit, there's no way you and I are standing up right now. We would not be on two legs. Any weaker, and we float off into space, and everything begins to fall apart, and you don't have the ability for stars and planets to attract and form. So gravitational force is a huge principle of fine-tuning. Here's another one. Cosmological constant. I did some background reading on this one in particular. And part of what I found is that this is really a difficult concept. it's presented fairly easily in the book, and I think in a good way. Robin Collins presents it in a way that is really good, but it's a fairly complicated topic. Because I don't have the background, I don't want to share ignorance exactly. I did learn a little bit. I do know a little bit about this. But basically, cosmological constant is what we refer to as the energy density of empty space. So space is not actually empty. There's a density there. There's a force there. And this is at least one theory behind what is happening in that space. It also explains this expansion speed of space in the universe. Now, this was part of Einstein's theory of general relativity. And here's the thing. He came out with that in, I think, 1917. And he later retracted what he believed about the cosmological constant. So he came up with the idea, but then later on, basically said that was a pretty big gaffe on my part. And what I read about it anyway was that it was considered one of his bigger mistakes by himself. He thought of it that way. Now, he was thinking of space as static, and so he was trying to explain how space can stay static. Well, Hubble came along later on after that and was able to observe that space was not just static, it was expanding. And so it began to kind of change the definition and the understanding of what was happening in space. So even though it's part of general relativity, it has changed since Einstein. Now, really what's happened, let me read to you a little bit of what I found, and rather than me trying to explain it. I think this describes it pretty well. Try to hang with me on this reading and ask any questions that you have. And maybe I or somebody else, Julie or one of my other, there's some scientists in the room, so maybe they can help. It says, in the context of cosmology, the cosmological constant is a homogeneous energy density that causes the expansion of the universe to accelerate. Originally proposed early in the development of general relativity in order to allow a static universe solution, it was subsequently abandoned when the universe was found to be expanding. Now the cosmological constant is invoked now to explain the observed acceleration. So Einstein said, I think that's why it's static. Now, currently scientists are saying, wait a minute, it's not total garbage like Einstein thought it was at one point. Instead, we now understand better the acceleration of space through the cosmological constant. So it is in its simplest realization, it's what's called dark energy. You may have heard that term, I don't know. Which is the more generic name given to the cause of the acceleration of the universe. So it was abandoned and readopted. And scientists are now, and Robin Collins now is saying, wait a minute, what they would say about this now is that this is regarded as one of the greatest problems, one of the things that they are trying to solve and understand facing physics and cosmology today. And here's the thing about cosmological constant. And you don't have to necessarily walk out of here, I think, feeling like you've got to explain what that is. But I would want you to walk out of here with an appreciation for how staggering this is. The number is so precise, it's so huge, it's incomprehensible. So if you were to describe it numerically, the chance of this thing, the fine-tuning of the cosmological constant, if you were to put it into a number, then you would say it is at least 1 part in 100 million, billion. Now, would anybody like to come up and write that on the board for me? That number. Here's the number. Have you ever seen a number that big? It's crazy, right? So this explains or helps us to at least begin to wrap our minds around how intricate this truly is. Let me stop there for a minute. What questions do we need to ask, clarify? So, in other words, this is, when you look at that number, this would be like saying, would you like to play the cosmic lottery with these odds? These are your odds. 1 in 100 million, billion. Did I get enough billions in there? That's your odds. Anybody want to play? Pretty good odds.
Are you saying that if you don't win, you're dead?
Yeah. You don't win, you're dead. I like that. Yeah. He gives an illustration in the video later, but I thought it'd be worth noting now and getting you thinking about it. He says, just to understand this number and the chances of this. If you were way out in space, he says, and you throw a dart at random toward the Earth, then that dart would have to successfully hit a bullseye that is on a trillionth of an inch in diameter, less than the size of a solitary atom. Anybody want to play now? Now, that's mind-boggling to me. And I think it is even to physicists, to be quite honest. It's hard to wrap our minds around. But it's part of our universe. It's part of what holds it all together. And so it's really fascinating on that level, isn't it? Okay, if you add together just these two principles of fine-tuning, gravity and the cosmological constant, you add those two together, multiply them, and come up with a number. Here's the number. Can you read that? 1 part in 100 million, trillion. What we're saying is, if that's the odds, would you believe that it happened by accident? If you're on Mars and you find that dome structure, do you say, wow, it's incredible that this just suddenly appeared here so finely tuned against those odds? Now that's just two examples of fine-tuning. All right. Everybody with me so far?
Yeah.
Any questions? All right. So, there's some other examples of fine-tuning. Let me get back over here to my notes. Other examples. The difference in mass between neutrons and protons. It's been a while since I studied that in school. Wow. Okay, so what would happen if there was a difference in mass, if you tinkered with the size, the mass of those? So the book says you increase the mass of a neutron by about 1 part in 700 and nuclear fusion in stars would stop. That's how finely tuned it is. It has to be just precisely the right mass. There would be no energy source for life. Another example of fine-tuning that allows for the anthropic principle. Let's do another one. Electromagnetic force. Anybody explain that? Anybody? Okay, I can't do it. But let me read it to you. Here's what the electromagnetic force is all about. In physics, the electromagnetic force is an influence that affects electrically charged particles. So, along with gravity, is the force that humans encounter most on an everyday basis. You didn't know that, did you? You didn't know.
I made it see.
You made a scene. You didn't know. And it explains most of the phenomena with which people are familiar. Let me see if this picture helps you at all. That help you? Try again? All right, here we go. That help you? You had to ask. I set you up. All right. It is responsible for electricity, magnetism, and light. It holds electrons and protons together in atoms, and it allows atoms to bond together to form molecules and drives chemical reactions. The force is also responsible for the solidity of a solid object and is the reason they cannot pass through one another. Does that affect anything in your life on a daily basis? Everything, right? So, just another note about that. One of the four fundamental forces in nature, the other three are the gravitational force, the strong nuclear force, and weak nuclear force. Electromagnetic force is the second strongest. You make the electromagnetic force slightly stronger or weaker, either way, and life in the universe would be impossible. Don't ask me to explain that, how that is. But that's what physics tells us. Slightly stronger, slightly weaker, can't happen. Just another example of fine tuning. Let me give you one more. What I just mentioned, strong nuclear force. My wife makes fun of me because she says I say that wrong. So if I say it wrong, I'm sorry. I'm trying. I'm from Texas. Give me a break. All right.
You could be president.
I could. In fact, who would vote for me right now? I had a feeling I would get some good response out of that. Thank you. Dun.
You would come back.
Four score.
You would come back.
I don't want it. All right. A couple of pictures here. Who can tell me what that is?
Mars.
Yeah, Mars. That's right. Can you see the dome structure? That is our beautiful sun. Here's another one. Somebody say it correctly for us. I don't think it's Chernobyl, but it is a nuclear power plant. Strong nuclear force, also known as the strong interaction, is the strongest force in the universe. 1,038 times stronger than gravity and 100 times stronger than the electromagnetic force. The only catch is that it only operates on length scales of an atomic nucleus, rapidly dropping off over longer distances. This force is what is liberated during nuclear reactions of the sort that takes place on the sun, power plants, and nuclear bombs. Strong force is described by the laws of quantum chromodynamics. Here's the thing. You decreased it by 50%. Just as an example, right? Which is tiny. 1 part in 10,000 billion. Sounds like a lot, it's really not. Compared to the total range of force strengths, and it would become too weak to prevent the repulsive force between positively charged protons in atomic nuclei from tearing apart from all atoms except hydrogen. So what you would be left with, if you tinkered with this, is hydrogen. You can't have a planet with just hydrogen.
You just can't live there.
Well, you can't live there. Yeah, that's right.
Unless you gotta go.
Unless you have to go.
If you have a dome. That's right.
What a coincidence that would be.
All right, let me wrap up this with saying this. Stephen Meyer, also interviewed in the book, says there are more than 30 separate physical or cosmological parameters that require precise calibration in order to produce a life-sustaining universe. That's what you could go away with tonight. Get out your phone, take a picture of that, and remember it. There are more than 30 of these fine-tuning principles that means you can be alive today. Now, I gave you two, right? I gave you gravity and the cosmological constant. And just those two multiplied together gave you that astronomical number that we can just, it took me a while just to type it out on my keyboard. This tells you that if you multiplied all of those things over each one 30 plus times, and each one has to be perfectly tuned in, not a little bit this way or a little bit that way, then only in that circumstance can you have life. Wow. Pretty impressive, I would say. Now, what I want to do is play the video for you of Lee Strobel on this chapter. Some of the stuff at the end of the video we won't cover tonight, where he talks about multiverse. We'll cover some of that next week. It's pretty fascinating. Does anybody know what multiverse is? Raise your hand if you've heard of multiverse. It's showing up more and more, yeah. Showing up more and more in some of the popular television shows. Is that where have you studied it or seen it, but you've seen it kind of showing up? So you might hear about this, but we'll cover it next week. But the first few principles are there. Let me check my time. Oh yeah, we're doing great. Before I play the video, anything that we need to clear up? Any reactions? Yeah.
Just given those few examples and for the universe, not to mention all of our bodies, that's what I'm more dealing with.
Yeah.
Physiology.
We're going to get to that, of course. Yeah, but our
It
bodies.
just makes me wonder how physicists like what's in Hawkins that it's not creator driven.
Yeah. Yeah, so in other words, it's so staggering. How can some of the scientists that know these principles say they're so driven by a philosophical belief that they're basically saying, here's what scientists are saying that don't want to acknowledge any type of creation, is that we still don't have an answer. We have theories that we can't prove, but we're going to keep looking until we can find a way, because they're just not willing to acknowledge, not willing to go there. But in the case of multiverse, what we'll talk about next week primarily, that's one of the arguments for how you can have such a finely tuned universe. And it's really absurdity. But all it would do is push back the idea that there's a creator to the next level, because then you would have to say, well, where did those multiple universes come from, and so on. So it's really, science is backed into a corner now in a lot of ways. Mark, did you have a comment?
One quick tidbit about
Yeah.
Mr. Newton. This was from a sermon given by the late great Adrian Rogers several years ago. He discussed a survey that had been done of modern day scientists where they asked, who was the greatest scientist that ever lived? And all the people in academia sent their results in. And they came up with Isaac Newton. Now the curious thing is that in academia, the greatest percentage of atheists reside in the physics departments. We know. So all of these scientists said, okay, well the greatest scientist that ever lived was Isaac Newton. In addition to the light and gravity studies, of course, the scientific method was his. Here's the curious thing. Isaac Newton wrote more on theology than he did on science. There were 12 volumes discovered.
Really? Interesting. Yeah.
He was a big believer.
Oh, yeah.
You're talking about these different fields, electric fields, magnetic fields, gravitational fields. I think it's very fascinating. We really don't understand what creates a gravitational field.
Yeah.
We can modulate all the others.
Right.
We cannot modulate gravitational field. If we could, we'd be flying.
Yeah. We still don't know that much about gravity. How is that possible? Yeah.
We know that gravitational bodies attract one another.
Right. We know some of the principles, but we still can't really fully explain it. Which is really, yeah, that's a great point, Ron. It's really interesting that science struggles with that one. All right, let's...
Because we have
we have a formula for it to measure it.
Sure, yeah.
But we don't have any way of controlling it.
No.
That's right.
All right, let's watch the video and gain just a little bit. You'll hear some of the same principles again, but what I'm hoping is that that reinforces. Now that you've heard it, this will help it soak in a little bit more. Okay, so can somebody grab the lights before I start? Just somebody back there. The three main switches there. Yeah. All right, here we go.
Since the beginning of time, all the matter in the universe has been governed by precisely balanced laws and constants. During an interview with Robin Collins, a philosopher with degrees in mathematics and physics, Strobel learned how these laws offer compelling evidence for a creator and conspire to make the universe habitable for life.
The laws of physics are balanced on a razor's edge for life to occur. For example, if you didn't have something like gravity that pulled matter together, you would never get planets, you wouldn't get stars, you wouldn't get any complex organisms. If you didn't have the strong nuclear force, there would be nothing to hold protons and neutrons together in the nucleus. And so you wouldn't have any atoms, so no chemistry. If you didn't have the electromagnetic force, you would have no bonding between chemicals. You'd have no light, and the list goes on. So you need all these sorts of fundamental principles have to be in place in order for life to occur. Wipe out one of those principles, wipe out one of those laws, no life.
Strobel learned that life also hinges on the precise strengths and relative values of many different physical constants. One example of this fine-tuning is the force of gravity.
Imagine a ruler divided up into 1-inch increments and then stretched across the entire universe, a distance of some 14 billion light years. For the purposes of illustration, the ruler represents the possible range for gravity. In other words, the setting for the strength of gravity could have been anywhere along the ruler, but it just happens to be situated in exactly the right place so that life is possible. Now, if you were to change the force of gravity by moving the setting just 1 inch compared to the entire width of the universe, the effect on life would be catastrophic.
No large-scale life forms could exist. Anything that was more than the size of a pea would be completely crushed. So you might be able to get life of a very, very primitive sort, such as bacteria, but you could never get conscious observers.
The strength of gravity is just one of at least 30 separate parameters that must be finely tuned to produce a life-sustaining universe. Another example is the cosmological constant.
The cosmological constant describes the expansion speed of space in the universe. If space expands too quickly, then the universe will spread out so quickly that material objects can't form. So you can't get stars and galaxies and planets, and the types of things that we, of course, take for granted in our universe.
Physicists have determined that the cosmological constant is fine-tuned to 1 part in 100 million billion 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 billion. Such precision has been compared to traveling hundreds of miles into space, then throwing a dart at the Earth and hitting a bullseye measuring 1/trillionth of an inch in diameter, an area less than the width of a single atom.
Just consider those two parameters, gravity and the cosmological constant. Their level of fine-tuning is to a precision of 1 part in 100 million trillion 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 trillion. I mean, that's like 1 atom in the entire known universe.
This fine-tuning is also evident at the atomic level. The strong nuclear force binds atoms together. If the strength of this force were to decrease by 1 part in 10,000 billion 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 billion, the only element left in the universe would be hydrogen. Again, chemical life would not be possible. The fine-tuning of the laws and forces of physics is so precise that few theorists are comfortable invoking mere chance as an explanation, unless our universe is not the only roll of the dice.
If the universe looks like it's fine-tuned for complex life, maybe there's a fine-tuner. Maybe it was fine-tuned for life. And this has certain unsavory theological implications. And so it's not surprising that those committed to a fundamentally materialistic view of reality would try to find an escape hatch. And the most popular escape hatch for this theological implication of fine-tuning is this idea of multiple universes.
As its name suggests, the theory of multiple universes proposes that our universe is not alone. Instead, it is part of a vast ensemble of universes, each with a different set of laws and constants.
If there's only one universe, then the conclusion that the universe looks fine-tuned because it is fine-tuned is inescapable. But if our universe is just one of a vast set, then you seem to have more resources to play with. Chance gets a new lease on life. I sometimes try to imagine what physicists have in mind that postulate this idea of multiple universes. I mean, what would the generator look like that creates them? Maybe it's like a giant monolith that has dozens of different dials, each of which has to be set to the right physical constant.
If we think of these parameters as dials, each of the dials is different. So if you produce enough universes with enough different dial settings, eventually, just by chance, you get one just right. So you might have to produce a trillion universes. But eventually, if you have a generator that's just spitting out just an enormous number of them, then it gets the right dial setting. And then by just chance, you get conditions right for life. So it's a huge cosmic lottery. That's the idea.
It's an interesting idea. I mean, there's really only one problem with it. There's no independent evidence that it's true. Besides, it really just pushes the question back a step, because we could still ask, who built the generator?
The suggestion of multiple universes strikes me as a desperate attempt to explain away the obvious, which is that the universe is finely tuned by an intelligence to sustain complex life.
You'll grab the lights for me. So help me out. Who did the fine tuning? Can I get a witness? Yeah, well, I mean, that's what we have to decide, right? We're free will people. We have the ability to think and study and reason. Is it a reasonable conclusion that these things happen by chance? I mean, that's what the video is asking, that's what the material is asking. Can we reasonably think that way, process that way? Or if not, does anybody in here, or do you know of any scientists that have a better conclusion? We'll get to some of the other theories in multiverse, hopefully some next week. Does that sound like a good theory?
My brain can't even wrap around that stuff, the multi-universe.
Yeah, and part of what we've talked about already with the Kalam argument the last few weeks is that if you go back far enough to that moment, where did that matter come from? If there was a big bang, if that's the way God started this thing, where did that matter come from? And so if you just did that with multiple universes, then where would all that matter come from? Where would the machine come from that produced it, and so on? It's really a fairly interesting idea. Now, in a not a good way, you know what I mean? So, it kind of brings us to scriptures like this, though. I've already shared this one with you, I think, the first week, but look at the way that those two highlighted phrases or words. Son is the image of the invisible God, the firstborn over all creation. For in him all things were created, things in heaven and on earth. Heaven there being Not necessarily the eternal type heaven that we're thinking about, but the heavens and the earth. It's always that pairing, meaning it could be the skies and everything that we see, everything that's known, right? Rulers and authorities, visible and, skip down, visible and invisible, thrones or powers, rulers or authorities, all things have been created through him and for him. He is before all things, and in him all things hold together. Paul must have been a pretty good physicist. Who's winning? Paul must have had a pretty good concept, right, from the Holy Spirit of something holding all these things together. That's the idea of this fine-tuning. That God has fine-tuned and understood so much more deeply than we have, even that scientists to this point have. Like Ron was saying about gravity, we still don't fully even understand gravity. Yet here's God doing all this fine-tuning on a scale that we can't even fathom in our minds. And He's holding it together. You could look at Romans. Again, Paul doing some pretty good science work, I think. Since what may be known about God is plain to these people who are experiencing wrath from God, because God has made it plain to them, and He says, here's how He made it plain. Since the creation of the world, God's invisible qualities, there's that word again. You know, the invisible qualities, the eternal power, His divine nature. You know, we always filter things like eternal power. We filter that through a spiritual lens, don't we? You've heard preachers say that, in Bible classes, you read that. And what if you filtered it through a more scientific lens and thought about those 30-plus principles of fine-tuning? That would be some pretty impressive eternal power. Divine nature being clearly seen, being understood from what has been made so that people are without excuse. If Paul can say that in the first century and say, you don't have an excuse, you can look around and see it. As little as they knew then about, they didn't even have the word science, right, at that point. And he's saying, you can look at nature, you can look at what God has made, the created order, and you can see that this was no accident. So what's so fascinating about this material and why I wanted to do the study and why you keep coming every week is because part of what we discover through science now and the amazing discoveries of science, that the more they discover, the more it points back to what Paul knew in the first century. No coincidence, I think, any more than all of those principles being so finely tuned for our universe. So, who did the fine-tuning? What comments do you have? Questions?
You know, again, it's interesting to me that, you know, here are these very intelligent folks who, you know, who can comprehend mathematics in such a way that I just can't even imagine.
Right.
They want to fight the idea of faith and belief in something they can't see. They want to fight it so hard that they'll put their faith in something they can't see and they can't prove.
Right. But more and more of them are coming to some sort of belief in a created order. That doesn't mean they're becoming Christians necessarily in every case, but more and more scientists are coming to the conclusion and examining the evidence that they can no longer disprove or doubt based on what they're finding, so they become theistic in some form or fashion. Some way they say, okay, I see that it has to be in some way created. That doesn't mean they're ready to surrender their life to Jesus Christ and become a new creation. But there's more and more of them that are intellectually honest enough to say, I can't do this anymore.
Anthony Flew was the poster child for atheism among the 4 Richard Dawkins in the God Delusion. Anthony Flew, if he's still alive, he'd be in his 90s.
Yep.
And around 2007, now he had written tons of books on atheism. He was literally the poster child for atheism. Most people haven't heard of him because he's much older and he's British. But around 2007, he had a complete change of heart. And so a reporter asked him, Mr. Flew, you spent your whole life writing about atheism, espousing atheism. How in the world could you suddenly become a deist? He said, well, I tell you, it was real simple. Two things. After 2005, when we finally mapped the human genome, I realized then the complexity of a single eye, for example, and the machinations that go into that are so much more complex than even what we know about the known physical universe. The notion that that could be by chance was preposterous. And number two, when I went back and looked at all of the founders of modern scientific disciplines, so we got Kepler, Kelvin, Boyle, Faraday, Newton, even Einstein. So all of these are fathers of our modern scientific disciplines, be it electromagnetics or Newtonian physics or whatever. They all, whether they started out that way or not, they eventually became believers in a designer.
Yeah.
Now, some like Einstein didn't believe in a God you prayed to, but he definitely believed in a designer of the universe.
Yeah.
So he said, who am I? Can I hang my hat on chance still? And even though I've written about it for generations, am I going to continue to hang my hat on that, which doesn't make any sense, or hang my hat on Mr. Newton and Mr. Faraday and Boyle and Kepler and Kelvin and so forth?
Yeah, very well said. Thank you for sharing that. I researched him a little bit a couple of weeks ago, and I may share a little bit of that. You know, you mentioned the eye. We're getting to the biological information in future chapters, but it's sad to me that he did admit to a creator, but you mentioned the word deist, which means a deist believes that there was a God that created and kind of spun it into existence and then let it go and backed off from it and was not involved on a personal level. And so he died not too long ago, a few years ago, and that's the way he died.
A lot of Christians were working on it too.
Yeah. Maybe, who knows? Maybe there was something there that
I don't know if you found
God grabbed hold of. We're about out of time. I want to thank you for being here. I know that this is challenging. It's challenging for me to present it. Just the cosmological constant, I think, is a fairly difficult concept for scientists to explain on some level, you know, and that they don't fully even understand all of those things. They're still working on those theories, but I hope that as the weeks go by and we lay on more and more layers, you've got some tools now in your belt, right? You've got Kalam, where you can say, I get that on some level. If you don't, and you want to know more about that, ask me, and I'll talk you through that. You can talk about the anthropic principle or understand something of that. You may not be able to fully explain it, you know, that's okay, but you've got a concept of that now. And some of those things then that enforce that fine-tuning. As we get into future chapters of the way that astronomy teaches us that our individual world is finely tuned. And then, of course, Julie began talking about even our bodies so finely tuned, and the discovery of DNA and how that enlightens so much of science. And so we'll begin to look more and more at those layers. And I hope by the end of it, you've got a pretty good case for a creator. So thank you for letting me share the material with you.